Okay, so let's do some more examples of simplifying fractions that have square roots in them. So in other words, we're going to be rationalizing. So we don't want any square roots in the top. So if I look at number 1, I have 3 over the square root of 10. So I want to check first, can I reduce anything between the numerator and denominator? Well, I have a normal 3 and then I have a square root of 10. So I have an outside number and an inside number, so I can't reduce between them. And I can't break down the square root of 10. So I'm going to go ahead and rationalize. So I need to cancel out the square root of 10. So to do that, I'm going to multiply the denominator and the numerator by the square root of 10. So now when I multiply these two things together, when you multiply identical square roots together, the square root just cancels out and you're left with the radicand. But if you're not sure about why, we get the square root of 100 in the bottom. Right, we get 3 square root of 10 in the top. And then the square root of 100 is just normal 10. Right, and then I want to see if I can reduce at the end. So 3 and 10 have nothing in common, so I can't reduce any further. So I am done. So number 2, I have 6 over the square root of 7. Again, I can't break down the square root of 7, and there's nothing I can reduce between the top and the bottom. So I'm good to go. I'm just going to do the problem, right? We're going to get rid of the square root of 7. So to get rid of a square root, we multiply it by itself into the numerator and the denominator. So that's going to give me 6 square root of 7. And then 7 times 7 is square root of 49. But the square root of 49 is just regular 7. So I get 6 square root of 7 all over whole number 7. I can't reduce 6 over 7, so I'm done. So now things do get a little bit more advanced if you have variables in there. So let's do a couple of those. Scroll down here. So we have some examples of ones with variables. So the key thing I want you to remember to do is reduce any radicals, right? Reduce/simplify radicals first. Right? That means break them down. So if I look, I'm just going to kind of do some scrap work here. So if I just have the square root of 18n to the 8th. So we know that we have an index of 2 here. So I can bring out n to the 8th. Right, and I'm going to divide that by the index number. And then I'm going to break down the square root of 18. That's going to be the square root of 9 times 2. So I'm going to get n squared here, because 8 over 4 is 2, times the square root of 9 is 3. And then I have the square root of 2 left over. So this becomes 3n squared square root of 2. So this problem here, right, my original problem, 4n over the square root of 18. Why did I put a 4 here? Oh my goodness, oh my goodness. Our index is 2. Okay, right, so that's a 4th power. So if you were looking at the screen going, I don't know where that 4 came from, neither do I. So that should be an n to the 4th on the outside. My bad. Okay, back to what we were doing. So I'm just copying down the original problem again. And then we just simplified the denominator to be 3n to the 4th square root of 2. So the first thing I'm going to do is I want to reduce these n's. So remember, this is n to the 1st. So if I have one n in the top and then 4 n's in the bottom, I can reduce that, and I'm going to get rid of the n there, and that's going to become n cubed. So rewriting what we have 4 over 3n cubed times the square root of 2. So now I want to get rid of the square root of 2. So I need to multiply it by itself to cancel it out. So I'm going to end up with 4 square root of 2 in the numerator over 3n cubed times the square root of 4. And then the square root of 4 is regular old 2. And then I can reduce here. So I can, right, 4 and 2, I can divide them both by 2. We're just dividing the outside numbers now. So that's going to reduce to 2 square root of 2 in the top over 3n cubed in the denominator, because when I simplify here, right, this is going to go away and become 1, and that will become a 2. And that's going to be our final answer there. Let's do one more together. Scrolling back up to see an original problem here. Okay, we have 5m cubed over 10m, square root of 10m. Okay, so I can't break down the square root of this. So what I'm going to go ahead and do is just get rid of the square root. So I need to cancel out the square root of 10m. So if I multiply that into the denominator, it will cancel out. So I'm going to multiply it also into the numerator. So in the numerator, I'm going to get 5m cubed times the square root of 10m, and then the square root of 10m times the square root of 10n, right? The square roots cancel out, and I'm just going to get regular old 10m in the denominator. So again, we're going to reduce here. So I can reduce 5 and 10, right? I can divide those both by 5. Okay, so I'm going to kind of scroll down. So that's going to become a 1 and a 2. Kind of just filling in some gaps here. Okay, and then if I have, we'll just do it in multiple steps. There's no reason to rush this. Right, I'm going to fill in the rest. And then I have m cubed over m to the first, right? So if I have 3 m's in the top and I take 1 away from the m in the bottom, right, this is going to become no m's in the bottom, and I'm going to replace this with a 2 exponent instead. So overall, my answer is going to become m squared times the square root of 10m all over 2. So we are going to work on that as our final answer.